So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the AQA AS Maths past paper of June 2018, paper 1 section A, and I'll include a question breakdown in the description below so you can see which question refers to which topic. So let's get started on this June 2018 paper 1 section A. So looking at question 1, it says 3 of the following points lie on the straight line. Which point does not lie on this line? Now, although it's a multiple choice and it's only worth 1 mark, there are several ways in which you can answer this question. One way, if you've got a graphical calculator, is to simply plot those points and see which one does not fall in line. Another one you could do is, if you've got time and you're very quick about this, is to actually plot the coordinates with a generally accurate set of axes. And again, you might need to go beyond that. Or you could do a table of values. So one thing you could do for this particular question is to write x and then y. And when you're doing a table of values, try and spot which one is not. So we've got -2, -1, 0, 1 and 2. And then if we plot the y on it, so we've got 14, 8, -1 and 6. So one way of spotting this is, again, looking at the difference between the values. So this should be -6, let me just add that there. So this here is going to be -5, and then if I continuing -5, then this number here would be add 5, so it's going to be 4. Then this number here should be 9, and that one would be 14. So here we can spot, by doing a table of values and filling in the empty coordinates, we can spot that -1, 8 is going to be our odd ordinate coordinate. Moving on to question 2, it says that a circle has the equation of x minus 2 squared plus y plus 3 squared equals 13. Find the gradient of the tangent to this circle at the origin. So first things first, from this equation we can see that the centre of the circle is going to be 2 minus 3 with a radius of √13. Now to work out the gradient of OC, so from the origin to the centre, well, if I take the origin as being my second coordinate, then C is going to be -3, and we've got -2, which then gives us a gradient of 3 minus 2. So therefore, the gradient of the tangent at the origin is going to be the negative reciprocal of this gradient. So it's going to be -1 over 3 over -3, 2. So that's going to give me 2/3. So our correct answer is going to be our third option. Then moving on to question 3, it says state the interval for which sine x is a decreasing function. So if I start by drawing my sine graph, which looks something like this, between 0 and 360, then where this graph has got a decreasing gradient is between this region here, and that region there is going to be 90, and then we've got x to 270. Now we make sure that you're not writing an equal sign in those inequalities, simply because at that particular point and that particular point the gradient is going to be at 0, so it's going to kind of be like a point, a flat gradient. So make sure that your answer just includes less than in your interval. So then moving on to question 4, it says find the first 3 terms in the expansion of 1 minus 3x to the power of 4 in ascending powers of x. So looking at the first power, or the first term I should say, is going to be 40, and it's the first term with the highest possible power, and the second term, which is minus 3x, to the lowest possible power. And if I word that out, that's going to be 1 times 1 times 1, which is 1. The second term is going to be 40, and then the first term with the power take away 1, and then with the second term to the power of 1. So that's going to give me 4 times 1 times -3x, which gives me -12x. Then, and let me just make that correct there, because that should be a 1 there. Then for the third term, I've got 4/2, then I've got 1 squared times -3x squared, so that's going to be 6 times 1, and then -3x squared is going to give me 9x squared. and that gives me a total of 54x squared. So then adding up these three terms, I get my final answer of 1 minus 12x plus 54x squared. Now moving on to 4b, it says using the expansion approximate 0.994 to the power of 4 to 6 decimal places. So for this, first things first, what I've got to do is make the bracket equal to this number here. That should be 994. And doing a bit of rearranging, that gives me 3x equals 0.006. So x equals 0.002. Then all I then need to do is substitute it into this. So I've got 1 minus 12 lots of 0.002 plus 54 0.002 squared. And if I type that all into my calculator, I get an answer of 0.976216. And there is my final answer to 6 decimal places. Moving on to question 5. Now this one's worth 5 marks. So it says point C has a coordinate of C2 and D has coordinates of 6D. The line y plus 4x plus equals 11 is a perpendicular bisector to the line CD. Find the values of C and D. So first things first, let's have a look at trying to find the gradient of this line here. So the gradient of y plus 4x equals 11. Doing a bit of rearranging, we get a gradient value of minus 4. So that means that the gradient of CD is going to be the negative reciprocal of minus 4. So that's going to be positive of 1/4. Now, and let me just highlight that because we'll come that into play. So then what we then discover is then working out the gradient of CD, taking D as our second coordinate, so I'm going to have D6 minus, and then my coordinates of C, which is going to be 2 minus C, and that equals 1/4. So then doing a bit of cross multiplying, we get 4D minus 2 equals 1 lot of 6 minus C, and then I get 4D minus 8 equals 6 minus C. And then doing a bit of rearranging, we get 4D plus C equals 14. I'm just going to put a little box around that. Then working out the midpoint, and let's use a different colour. So let's go for this. So here, working out the midpoint of CD. Well, that's going to be, if I get those two coordinates back on the screen. So here we've got two x coordinates added together. So it's going to be C plus 6 divided by 2, and we've got 2 plus D divided by 2. Now we know that this point lies on this line, so sub this in. So let me just use a different colour. So what we're going to do is we're going to sub this into y plus 4x equals 11, because we know that that's a point that passes through this line. So then what we've got is we've got 2 plus D over 2 plus 4 lots of C plus 6 divided by 2. Just extend that bracket, and that all equals 11. So then multiplying everything by 2 and doing a bit of simplifying, we get 2 plus D plus 4 C plus 6 equals 22. And then doing a bit again, a bit of simplifying, we get this. And then so what we get is we get 4C plus D equals minus 4. So then from this we've got our second equation. So then using simultaneous equations, we've got C plus 4D equals 14, and we've got 4C plus D equals minus 4. And again, I can use my calculator to work out those values, or if you haven't got a Casio calculator, which it would be quite rare for this course, you would just solve it as you would at GCSE level, but we should have C equals minus 2 and D equals 4. So moving on to question 6, it says that ABC is a right angled triangle. D is a point on the hypotenuse AC such that AD equals AB, and the area of the triangle ABD is equal to half of the area of triangle ABC. And the question is asking us to show that tan A equals 2 sine A. So for this, let's start by first just marking what we know. So we know that this is a right angled triangle, and we know that point D is somewhere on the line of AC. So let's put that there. Now it also tells us that if we just call that D, so it also tells us that AD is equal to AB. So if this is going to be X, then this is also going to be X. It's going to be an isosceles triangle there. So then looking at this fact here, then what we know is if I then work out the area of triangle ABD is equal to, and if I just call that angle A, is going to be a half of X times sine A. So then from this, what we then do, if I just simplify this, I get half X squared sine A. So that's the area of triangle ABD. Now if that's the area of this triangle here, then that's half of the main triangle, then that basically means that the area of ABC is going to be twice the size of triangle ABD. So that's going to be 2 times a half X squared sine A, which gives me X squared sine A. Now if I then work out let me just put a little bubble around that, so that's the area of triangle ABC. So then for me to then work out what this length here, what AC is going to be, so then what that basically means then is using half AB sine C for triangle ABC, then that's going to equal half of times AB times AC times sine A, and that equals this expression here, which is X squared sine A. Now I know that AB equals X, so I can replace that with X. So what I then end up with is a half X AC times sine A equals X squared sine A. Then doing a bit of cancelling, well that X cancels with one of those X's, the sine A cancels with sine A, and what I'm left with is that half AC equals X, so AC equals 2X. So then what I've got then is I know that this hypotenuse of this triangle is going to be 2X. Now you might be thinking to yourself, well, where are we going with this? Well, if I take that triangle out again, so let me just draw this triangle here, and this is ACB. This length here is 2X, and this length here is X, and this is angle A. So then what I can then do is know that cos A, which is cos is adjacent over hypotenuse, is going to be X over 2X, which is equal to a half. So if cos A equals a half, using the exact values of trig, I get that angle A is going to equal 60 degrees. So then from this, then sine 60 is root 3 over 2, and tan 60, which is root 3. So then from this, what I can then establish is that then if I do 2 lots of sine 60, well that's going to be 2 times root 3 over 2, which is just root 3, which is equal to tan 60. So therefore what I've then proved is what they've actually wanted me to show, so tan A equals 2 sine A. Then moving on to question 6b, it says show that the equation given in part A has two solutions where A is between 0 and 90. So for this, all I need to do, then if I write down the equation, which is tan A equals 2 sine A, well, using a trig identity, that I know that tan can be written as sine A over cos A, which is equal to 2 sine A. I take the cos A over to the other side, so I get sine A equals 2 sine A cos A. I then take it all onto one side, so I get sine A minus 2 sine A cos A equals 0. Then from this, what I can then do is factorize. So I've got sine A equals 1 minus 2 cos A equals 0. So then either sine A equals 0 or 1 minus 2 cos A equals 0. So for sine A equals 0, A equals 0. And then for this, if I just do a bit of rearranging, I get cos A equals, it's going to be a half. So then A equals 60. It then says state the solution of which of these two answers of A is going to be appropriate. Well, I can't have an angle with 0 degrees, so then it's going to be 60 degrees. And then looking at question 7, it says that prove that when n is a prime number greater than 5, then n4 will have a final digit of 1. Well, prime numbers greater than 5, so all prime numbers greater than 5 will end in either a 1, 3, 7 or 9. So then looking at the last digit of n to the power of 4 will always equal the last digit to the power of 4. So if the number, or the prime number I should say, so if the prime number ends in a 1, then 1 to the power of 4 equals 1, which ends in 1. Then if the prime number ends in a 3, then that's going to be, then the last digit will be 3 to the power of 4, and 3 to the power of 4 is 81, which ends in 1. Then if the prime number ends in a 7, then the last digit will be 7 to the power of 4, which is 2401, which ends in 1. And then if I just move this up, so then if the prime number ends in a 9, then the last digit will be 9 to the power of 4, and 9 to the power of 4 is 6561, which ends in 1. So ultimately the final digit will be 1. So therefore that the statement is proved by exhaustion. Then moving on to question 8, it says Maxine measures the pressure in P kilopascals and the volume V litres in a fixed quantity of gas. Maxine believes that the pressure and the volume are connected by the equation of P equals CV to the power of D, where C and D are constants. Using 4 experimental results, Maxine plots log 10P against log 10V as shown in the graph below. And for the first part, it's asking us to find the value of P and the value of V for the data point labelled A on the graph. So at A, now here we've got a coordinate of what is going to be minus 0.15, and it's got a y ordinate of 2.18. So using this, what we can then see that from our x ordinate, which uses log 10v, that log 10, oh, don't know why I keep doing that, so log, and then we've got 10v equals minus 0.15. So then do being a rearranging, we get v equals 10 to the power of minus 0.15, and if I type that into my calculator, I get a v value of 0.708 to 3 sig fig. Then if I do the same for the y ordinate, then I get log 10p equals 2.8. So p equals 10 to the power of 2.18, and if I type that into my calculator to 3 significant figures, gives me 151. Then moving on to question 8b, it says calculate the value of each of the constants c and d. So what we need to do is work out the equation of the line. So if I go back to this particular graph, then what I notice is that the original, or let's go back to create more space. So the original equation is p equals, and it's cv to the power of d. Now, writing this in forms of logs, if I take log of all sides, so I get log 10p equals. Now, when we're multiplying, we add, so that's going to be log 10 of c plus log 10 of v to the power of d. Then I can move that d to the front, so I get log 10p equals log 10c plus d log 10v. Now, from this equation here, I can see that my gradient is going to be equal to d, and the y-intercept is going to be equal to log 10c. Because again, using y equals mx plus c, that is going to be my gradient. So then if I then go back to my graph here, and I pick two roughly generally nice coordinates, so let's go for and draw a triangle. So let's use this point here and the y-intercept. So looking at this, so this point here is 2 points. Actually, let's go for this point here. So you want to pick a nice coordinate and have your triangle as big as possible. So at this point here, I've got a x ordinate of minus 0.2 and a y ordinate of 2.25. Then at this point here, that's going to be at, well, I make it at being at 0, and it's at 1.97. So then using these two coordinates, I can then work out the base and the height of this triangle. So this is going to be 2.25 minus 1.97, and typing that into my calculator, that gives me 0.28, and this length here is going to be 0.2. So then the gradient is going to be 0.28 divided by 0.2, and that gives me an answer of 1.4. So then going back to the question, so I can then say that the gradient is equal to minus 1.4 because the line is going down, and then the y-intercept, which is log 10c, and if I go back to the graph, I can work out that the y-intercept is at 1.97, so that's going to be equal to 1.97. So let me just go back and write that the gradient, so d equals minus 1.4. Let's put a little bubble around that. And then from this I get c equals 10 to the power of 1.97. If I type that straight into my calculator, I get an answer of 93.3, I think. Let me just quickly type that in. So we get 1.97, and yep, so 93.3. And so there are my two values of D and C. For the next question, it then says estimate the pressure of the gas when the volume is 2. So then going back and filling in the values, I get P equals, and it's going to be C, which is 93.3 times v to the power of minus 1.4. So that's just substituting numbers in. So here with this question I've got v equals 2. So p equals 93.3 multiplied by 2 to the power of minus 1.4. And if I type that straight into my calculator, I get an answer of 35.4, and that's to 3 significant figures. Then moving on to question 9, it says Craig is investigating the gradient of the chord of the curve of the equation of f of x equals x minus x squared. Each chord joins the point 3 minus 6 to the point of 3 plus h, and then where we substitute 3 plus h into the function. And the table shows some of Craig's results. And the question 9.8 says show how the value of 5 minus 5.1 has been calculated. Well, in terms of the gradient, how the gradient is calculated is by doing f of x plus h minus f of x all over h. So to work out 5.1, what they've done for part A, let me just do this over here, is they've taken f of h minus 1, f of x plus h, which is minus 6.51, and then they then subtract the f of x value, which is minus 6, and they have that over h, which is 0.1. So then type this all into my calculator, so minus 6.51, and it'll end up being plus 6, all divided by 0.1, gives us an answer of minus 5.1. Then moving on to question 9b, it says complete the third row of the table. So the third row of the table, well, for this number here, if I just put that there, then x plus h is basically just going to be 3 plus h, which is 0.01, which gives us a value of 3.01. Then for this value here, what I'm then going to do is I'm then going to substitute 3.01 into the f of x function of x minus x squared. So if I type that all into my calculator, so in other words, what I'm going to get is going to get 3.01 minus 3.01 squared, and typing that into my calculator gives me an answer of minus 6.0501. Then to work out the gradient, well, for this I use this formula here. So then this value here is going to be, and it's going to be minus 6.0501 minus f of x, which is minus 6, all divided by h value, which is 0.01. And if I type that all into my calculator, I get an answer of minus 5.01. Then for 9c, it says state the limit suggested by Craig's investigation for the gradients of these chords as h tends to 0. Well, if we keep carrying on, then what you'll tend to find is that the gradient value is basically going to tend to get to minus 5. So as h tends to 0, the gradient is going to get closer and closer to minus 5. So then looking at question 9d, it says using differentiation from first principle, verify that your result in part C is correct. So looking at this, let's start by writing down the initial coordinates. So we've got 3 minus 6, and the other coordinate was 3 plus h, and the y ordinate, when we substitute 3 plus h into x minus x squared, so that's what y equals, then the y ordinate is going to be 3 plus h minus 3 plus h squared. Now, knowing that the gradient is equal to y2 minus y1 over x2 minus x1, and using these coordinates, then what we get is that the gradient is going to equal y2, which we'll just say is this. So this is my y2 and this is my x2. This is going to be my x1, that's my y1. So what we then get is the gradient is going to be 3 plus h minus 3 plus h squared, and then it's minus my y1, which is minus 6. And that's all over x2, which is 3 plus h, minus x1, which is 3. Then simplifying all of this, what we get is we get 3 plus h minus, and then it's going to be 9 plus 6h, or plus 6h, plus h squared, and it's going to be plus 6 all over h, because the 3's will cancel. Now simplifying, expanding all the brackets out, then what we end up with is we end up with minus 5h minus h squared all over h. So then if I cancel a h out, then what we end up with is minus 5 minus h. So then as h tends towards 0, the gradient equals minus 5, which is exactly what I got in part C. Then moving on to the last question in section A, it says that a curve has the equation of y equals 2x squared minus 8x root x plus 8x plus 1 for values of x which is greater than or equal to 0. Prove that the curve has a maximum point at 1, 3 and justify your answer, and it's worth a mammoth 9 marks. So first things first, let's start by writing this and differentiating this equation. So I've got y equals 2x squared, which is fine, but I want to try and write this in the next term in terms of indices. So that becomes minus 8x, and then it becomes x to the power of a half, plus 8x, which is fine, and plus 1, which is also fine. So then collecting, just simplifying this, I get x times x to the power of minus 1, so that's going to be minus 8x to the power of 3 over 2, plus 8x plus 1. Now from this, what I can now do is, now I've got it written in indice form, I can now differentiate this expression. So dy over dx is going to equal 4x minus, and it's going to be, and again with differentiation you're lowering power by 1, move the power to the front, lower by power by 1, so that's going to be 8 times 3 over 2, so 8 times 3 is 24, divided by 2 is 12, so it's going to be 12x, and I lower the power by 1, so that becomes a half, and that becomes plus 8. Then from this we can then say that it's going to be a stationary point when dy over dx equals 0. So if I make this equal to 0, so we get 4x minus 12x. Actually, let me just write that so that we've not got a line in between it. So what we've then got is 4x minus 12 root x plus 8 equals 0. Now, and it's just by looking at it, we can't actually see a quadratic, because typically when we're practicing these questions we tend to always get a quadratic equation. So what we're going to do here is we're actually going to let y equals root x. Now using this substitution, then if we've got x and we've got y equals x root x, then that's going to be 4y squared, because root x squared gives me x, and it's going to be minus 12y plus 8 equals 0, and then I can then divide everything by 4, so I get y squared minus, and it's going to be 3y plus 2 equals 0. I can then factorize this, so I've got y minus 2, y minus 1, so y equals 2 or 1. So then from this, what I can then establish that root x equals 2 or root x equals 1. So then as the question is asking me to prove that the curve has a maximum point at 1, which is what I've done, because we've got this here, so therefore x equals 1. So for it to have a maximum point, what I then need to do is then do the second derivative. So if I then work out dy squared of dx squared of this, then what I end up with is 4 minus, and it's going to be 6x to the power of minus a half. Then if I then make x equal to 1, then what I end up with is 4, and then it's 6 over root 1, which then gives me a negative value. So here what I've then got is, which is less than 0, so therefore a maximum point when x equals 1. Now one thing I haven't done is actually found the coordinate, so when x equals 1, y equals, now again from this what I'm then going to do is substitute y x equals 1 into the equation, so sub x equals 1 into y equals, and the original equation was 2x squared minus 8x root x plus 8x plus 1, and that gives me a y value of 3. So therefore it's a maximum point at 1, 3. Then for part 10b it says find the coordinates of the other stationary point of the curve and state its nature. So from this, well, we know that the other stationary point is when root x equaled 2, so therefore x equals 4. So then if we then substitute that into my second derivative, which if I just remind what the formula was, which was 4 minus 6 over root x, or the reciprocal 6 over root x, then here if I'm substituting x equals 4 into it, I end up with 4 minus 6 over root 4, which is 4 minus 3, which is greater than 0. So therefore it's a minimum point at 4, and then if I then, when x equals 4, I then want to find out the y ordinate. Y equals, remember that the formula for y was 2x squared minus 8x root x plus 8x plus 1, and if I substitute that into this, I get a y ordinate of 1. So then it's going to give me a minimum point at 4, 1. And there we go.